All right, in this problem, you're told that the cosine of theta is root 5 over 4. All right, couple ways to approach these problems, and I'll show you both of them. Okay, the first way is the way that I would prefer, simply because it allows you to visualize what these ratios are actually intended to represent. And that is, if you can draw a right triangle. Again, anytime you're dealing with the sine, cosine, and tangent trig ratios, they're referencing the ratio of sides of a right triangle. So if we know that cosine, we can assign either of these acute angles to be theta, and we know that the ratio is what cosine is adjacent over hypotenuse. So the ratio will be root 5 to 4, the adjacent side over the hypotenuse. Now, it's not a guarantee that these are the exact lengths, but the ratios are the same. Okay, and so if we needed to find the other two trig ratios, the sine and the tangent, it requires us to find what this missing leg is. Well, the missing leg can be found by using Pythagorean theorem. And so if we look at the relationship that, let's call it a squared plus the other leg, root 5 squared, is equal to the hypotenuse 4 squared. And then we simplify what we have. When you square a radical, a square root, you simply cancel the power in the radical, leaving a 5. When you square 4, you get 16. Subtract a 5 from both sides and extract the square root. Okay, so you wind up getting a is equal to root 11. So when you set up now your other ratios, you can simply use sine, which is opposite root 11 over hypotenuse 4. So there would be your sine ratio, root 11 over 4. And then your tangent. Your tangent is opposite root 11 over adjacent root 5. And so what you need to do here, you can manually simplify this by rationalizing the denominator, multiply by the radical over itself. So root 11 times root 5, you can just combine that product inside your radical. So you get root 55. And then root 5 times root 5 is root 25, which simplifies to 5. So square root of 55 over 5 would be the tangent ratio on this. Okay, now, the other way that you could possibly do this, and again, depending on what form they ask you to put your answers in, is you could actually find what the angle measure is. Okay, so we could have taken this original given information, and we could have solved for theta. And to do that, we would take the inverse cosine of it. And so if we were using our calculators to find the inverse cosine of the ratio square root of 5 divided by 4. Okay, now, when I set this up and solve, in exact answer, it doesn't give me any new information. It just repeats what I have. So you may need to put it in decimal form. So your angle measure is approximately 56 degrees. Okay, and so what you can do here is you can now find the other trig ratios of that same exact measure. So let's say I wanted to find the sine of theta. I could just calculate the sine of, and I could just enter the exact same thing. Here's my exact answer, and so it allows me to put it into the exact form, root 11 over 4. So that confirms what we did by hand. Okay, and then we could also find the tangent of this by calculating tangent of, and again, just go up, highlight the exact answer. Notice I'm not choosing the decimal form, because if I chose the decimal form, it would give me an answer as a decimal. So for this particular case, since it's asking for the exact answer, I could just choose the exact form, and again, it confirms root 55 over 5 as my correct solution. I don't care which one you use. Again, this one allows you to visualize the relationship that sine, cosine, and tangent have with right triangles. This one allows you to get more familiar with your calculator. Any other questions on the homework from 5.4?